All right, party people, we are in polynomials. Turns out we're just going to be calling this kind of day one of polynomials because we'll be skipping around chapter 6. So technically it might be labeled as 6.1, but it was formerly 6.3. Anyway, moving on. We're talking about polynomials. So we're going to classify polynomials and write them in standard form and evaluate them. So yay! All right. So here we are with a monomial, okay? A monomial is a number, a variable, or a product of numbers and variables with whole number exponents. So again, number, variable, or a product, all right? We'll go over some examples right down here. So let's see. A number, so let's say 5, super. A variable, okay, how about x? A product of numbers and variables, so maybe negative 7xy. So we've got a number and two variables. And maybe a variable with a whole number exponent. So if we take a look at that one, how about 0.5 x to the fourth? Super, that's a whole number. All right. So those are our monomials. And what is not a monomial? Well, let's see. Whole number exponents are not integers necessarily, meaning -2, so we can't have negatives as our exponents. We also can't have any, notice it says product, which means not addition and not subtraction, okay? And so in that case, we are not going to have 4x minus y, okay? That's actually two different monomials. And then division with your fraction and your variable being in the denominator, not happening. So those are not monomials versus are monomials. Super. Then we look for the degree of a monomial. So the degree of a monomial is the sum of the exponents of the variables. So, for instance, the degree of this monomial, 4. The degree of this monomial, a 1 and a 1, so 2. The degree of this monomial, 1. And then the degree of this one, a little tricky, it's actually x to the 0, because remember, anything raised to a 0 power is actually 1, and so the degree is 0 for that one. So it's the sum of the exponents of the variables, and a constant, of course, as we just saw, has a degree of 0, and so this is called a constant right here, because it's just a number and it's never going to change, so it's constant. All right, so taking a look at some examples here, we're going to find the degree of each monomial. So the degree of this one here, this has a degree of 0, of 4, and 3, and so 0 plus 4 plus 3 is going to make 7 for your degree. 7 degrees is not really what it is, but the degree is 7. The next one, a 7, again, number has a degree of 0, and every variable has a degree of 1. So 0 plus 1 plus 1 means that the entire monomial has a degree of 2. And then the last one, again, if you're looking for a variable, it's actually got a 0 power, and so that means we're talking about 3 times 1 for that piece. And so the degree is going to be 0. And I'm actually going to take out this equal sign because that's clearly not equal. Okay. So just to remind you, the terms of an expression are the parts being added or subtracted. So I kind of mentioned it a little bit earlier when I talked about this one, because this is actually a term and this is a term, which is why it's not a monomial anymore. This one's actually a binomial, because it's got two terms or pieces separated from addition or subtraction. So just so we can look at them, we've got some polynomials, poly meaning many, so many monomials. So a polynomial is a monomial or a sum or difference of monomials. So multiple things being added or subtracted. So here we are, x to the fourth, 2x to the third. Each of these pieces are a term. And so there are 5 terms. This one over here, kind of complicated, but it only has 3 terms. But it does have a lot of variables involved, but 3 terms. So the degree of a monomial matches the term with the greatest degree. So if we look at each of these terms of this first one here, this is degree of 0, 1, 2, highest power is 3, and then 4. So it turns out that this first one has a degree of 4. The second one here is interesting because this first piece has 5 for its degree, the second piece has 5 for its degree, and the last one has 4 for its degree. So either way, it's not like one of them like wins or something of the 5. We would just say the degree is 5. All right. So taking a look at some polynomials, we're going to find the degree of each polynomial, again, by identifying the degree of each piece and then finding the largest one. So the degree of this piece is 7, degree of this piece is 3, because again, numbers don't have degrees, they're all 0 for their degree. And so which one's the greatest? 7, and so it's a 7th degree polynomial. This next one here, again, tries to trick you with all these fractions in it, but really we're just looking at the powers. So this one has a degree of 0 because it's a number. This one has a degree of 4. And this one has a combined degree of 3 with the 2 and the 1. So which one's the highest? The 4th degree, so 4 degrees. It's a 4th degree polynomial. All right. Then we move on to standard form, because up until now you've kind of seen them in random order, but it turns out that standard form is written with the terms in order from greatest to least. So if you take a look back at this one, for instance, definitely greatest power here, and then it goes down sequentially until we get to 0. This one here did technically go in standard form as well, because we were talking about the 5th degree and then the 5th degree again, so it's kind of hard to choose which one to go first, and then 4th degree. So you want to always start with the highest degree first, so greatest to least degree. An interesting part about that is that we also go in alphabetical order, so let's say that rather than degree of the term, you have just everything having a degree of 1. Well, then after everything having the same degree, you would go in alphabetical order. And that kind of goes for multiple pieces within. So notice here I've got an x, y. X is first and then y because it is in the alphabet as well. So we like to keep things in numeric order, but then also in alphabetical order. Then we have something called a leading coefficient, and a leading coefficient has to do with the degree of the polynomial. So it's the number in front of the first term or the term with the greatest degree. Because it says when written in standard form. So just that we have that. So of course we're going to do an example here where we're going to write it in standard form. So again, highest degree to lowest degree. So identifying which are terms, this one here definitely has the highest degree. So negative 7x to the 5th. Notice that you keep the negative or the subtraction sign with the piece behind it. So don't forget about that. And then we also have the next one, which would be the next highest power of 2, so plus a 4x squared. After that, the next highest degree is this one, which has a 1, so a positive 6x. And then the last one there of 9. And so that's in standard form. They want us to give the leading coefficient, and so in order to get the leading coefficient, this is our leading term. And so the leading coefficient is the number that's way out front, negative 7. Don't include the x to the 5th, okay, because that's not the leading coefficient, that's the leading term. We don't want the x to the 5th part, it's just negative 7. All right, next one here, we're putting it in standard form as well. So again, just identifying what is the highest power. Looks like it's 6, so we'll start with y to the 6th. After that, we have a y squared. And after that, we have a y to the power of 1. And then they want us to find the leading coefficient. So this is the leading term when it's now in standard form. And so the leading coefficient is actually a 1. So as much as you don't see the number out front, the number that would be way out front that would actually allow us to keep y to the 6th would be a 1 versus like a 0 or something. All right, so we're also going to name some polynomials. So based on the number of terms and the degree, which we now know how to count and determine, we can actually name things. So let's say that something has a 0 degree. We already talked about that one, and that one is a constant. So if you have a polynomial that has a constant as its degree, you have the number 3, for instance. All right. The next one here, if you have a degree of 1, we've already talked about those in algebra, previous algebra courses. They're linear, right? They're a line. That's the degree of 1, because again, thinking back to y equals mx plus b, this has a power of 1 up there. All right, then we have a power of 2, which is known as our quadratics. And then we have a power of 3, which is known as cubic, because we're talking about the fact that a cube is in 3 dimensions. 4 is going to be quartic. 5 is going to be quintic. Maybe you've heard of quintuplets. That would be 5 children at a time. Yikes. Okay, and then literally after that, if it's 6 or more, you just say it's a 6th degree, 7th degree, 20th degree, whatever it happens to be. So we don't really have names. I mean, we do, but we just don't use them. So 0 to 5, and then after that, we just kind of say the number as its degree. And then we have our names for a polynomial. So this is based on the terms. So rather than the degree or the exponent, we're now talking about terms. So how many pieces are separated by addition or subtraction. All right. And so if you have one term, we're going to call it, as you may have seen, monomial. Mono meaning 1. 2, we're going to have a binomial. Again, bi meaning 2. Trinomial for 3. And then literally after 3, if there's 4 or more, we just go with the word polynomial, which we talked about earlier, but poly meaning many. So monomial is 1, binomial is 2, trinomial is 3, and then poly is just everything after that. So now that we kind of understand how to write them in standard form and how to identify them, let's go ahead and name them. So we're going to classify each polynomial according to its degree and its number of terms. So it's kind of like 2 names. So this first one here, based on its degree, is going to be a, again, 3rd degree, so cubic. And then because there are 2 terms, we're going to call it a binomial. So cubic binomial for that guy. The next one it's in standard form, so 6 is its largest degree. And so again, 6 means that it's just a 6th degree. Oops. And then based on the number of terms, we have 1, 2, 3, 4 terms. And so it's going to be a 6th degree polynomial because we don't have a word for anything 4 and above. All right, and then the last one has a degree of 1, and so we're going to call it a linear. And then it only has 1 term, so monomial. So sometimes the assignment will talk to you about, this linear monomial, and you're like, what? And linear monomial, it just means this equation that's sitting there, okay? It just happens to indicate then that it's a degree of 1, and it has 1 term. All right, so those are our notes for, again, polynomials. You can call it 6-1, you could call it formerly 6-3, but either way, polynomials, introduction.